Hey, you tons, thanks for coming, guys. Okay, so we're going on to IGCSE bonding. Oh, who was first in the chat? Zyno was the first in. I love that. Jack Stilling, wait, have I managed it? Have I done it? In my screen, I got a first comment and like, probably the delay. Right, okay, guys. Let's share screen and crack on. So today we're going in, this is lesson. Now, what I've actually done is, because we've been working through bonding and we went all the way through ionic. And what I'm now doing is going into the next set of bonding. So I've linked it by doing this as lesson 8 in GCSE for bonding. So this is now metallic bonding. So lesson 8 GCSE, I believe. That's what it said anyway. So I'll share my screen and we can crack on. I don't have my clip cam, so I'm just doing my normal one today. Wait, Mr. Duncan, who came in first? I think it was Zyna. I think Zyna was first in. He would know. Yeah, Zyna was in first. It's the only thing you guys care about. Brilliant. He would know. Yeah, Zyna was in first. It's the only thing you guys care. Okay, so it seems to all be working all right. It's my YouTube video playing. Right, so, I'm actually going to close down the YouTube video itself. Don't need to see that. I will throw the, I've just closed it with the chat. Eek. I'll try that again. No, that one, and then close that down, and then eek. I'll try that again. Sounds not very good, is it? Pop out that one, and then close that down. I don't know why. And then I'll try that again. Sounds not very good, is it? Stop. Go away. The sound is terrible. So what I might do, move that over to that screen. There we go. It's got chat there. And I'm also just going to fiddle around with my microphone for a second. Let's go audio. Let's change that to that one maybe. Give that a try. Echo cancellation. Try that. Let me know if that's any. It sounds fine. It's so weird hearing Mr. Duncan twice. Okay, right, guys. Let's flip into tablet mode and crack on. So, 3 learning objectives today, folks. There we go. My tablet is going crazy. And just grab my mouse. There it is. Got a mouse. So if I just want to bring the chat back and put that back over onto the screen. There we go. So at least I can see when people are asking questions. Cool. Meter. Hi, Meter. So today's lesson is on metallic bonding. So as I said, lesson 8, I believe, in the sequence. Well, that's the last one I remember doing. I'll just go check that, actually. I can actually see that from a bonding perspective. Word equations, yes. The last time we did this was here. That brought us to the end of ionic, and now we're moving on to metallic. There we go. Oh, I'm going to move that one. Move that if I can. Oh, won't let me move it. Oh, there we go. There we go. I think that worked. There we go, metallic. Okay, 3 learning objectives. Number 1, be able to describe the bonding in metals. Number 2, know the properties of metals, and then understand conductivity and malleability based on its structure. So I think the first thing we should actually do, I'm actually going to do these learning objectives out of order. The first one we should probably do is know the properties of it, because you guys have been taught these already in Key Stage 3. So first thing let's do, I'll leave those learning objectives there, so we can do properties of metals. Let's see if I can shrink my pen a bit. There we go. Properties. And the great thing is there aren't many of these. Properties of metals. And can I just point out that these really do, I don't know if you guys have ever seen the TV show Family Fortunes, this idea of our survey said top answer. So the number 1 property of metals, number 1, is they conduct heat and electricity. Top property of metals. Number 1. Number 2, they are malleable. Malleable. Now the word malleable means can be shaped can be shaped when solid. When solid. Can be shaped when solid. So we can bash them with a hammer and change their shapes. Property number 3 is ductile. Ductile means they can be stretched into wires. Stretched into wires. Now, just to say, I'm now going to tie these two together. The reason why I tie them together is because they have the same explanation. Same explanation. There's no difference in the explanation for it being malleable as ductile. At this point, I'm going to now underline this and do number 4. Now, what I'm going to now say is, please don't write these down at GCSE. Oh, God, don't write these down. I'm doing it because of year 7. Yeah, I've got to do them because they're year 7, because everyone goes, but I know that metals are silver and shiny. Ugh, silver and shiny. I just hate it. Yeah, please, please, please do not say this at GCSE. Just to show you why, yeah, because metals don't have to be shiny and they don't have to be silver either. Yeah, so if I do powdered iron, yeah, powdered iron images, it is not, I'll put powdered iron. It is not shiny and it is not silver. Just to tell you which one of these are, the one on the left, so this one here, full screen snip, this one here, there, that is iron solid, that is iron powder. And this one is magnesium powder. Yeah, but they are not silver and they are not shiny. So please don't write that down at GCSE. It's fine being given it at year 7, but I'm just going to ask you guys, delete. Please delete it. It is not, our survey said, top answer. I will add another one as well, which is sonorous. Ugh. Sonorous. What that means is when hit with an object, they create a sound. Dong. Yeah, that's sonorous. Don't use that one either. Just, these are what I need you to learn. Learn those, please. It does upset me sometimes when people start quoting silver and shiny to me at GCSE, and I just want to slap them and be like, grow up, become more than 7 years old. Anyway, so, but at least we know them. There is another one I don't mind. There is another one, number 6, which I don't mind you having, which is they are strong. Yeah, we know that metals are strong, they are strong materials. Yeah, and that one I don't mind at all. You can keep that one. The reason being is what they're going to do is they're going to give you objects made from metal. So let's think about a GCSE question. I'll try and make that a bit smaller. Question number 1, what property, oh, I think my pen battery might be dying. Hang on one sec. I might have some spare batteries with me. Or not? Oh, darn it. I don't think I do. No, I don't have any spare batteries with me. Oops. Fingers crossed it lasts. So what property of metals make them ideal for ... A bridge. Yeah, a bridge. Answer, high strength. Yeah, high strength. Yeah, only explanation. B, a frying pan. Yeah, a frying pan. Yeah, and this one is good conductor of heat. Why C? C. Electrical cables. Electrical cables. And you will say, and this would be 2 marks. This is 1 mark. This one's now 2. That's 1, and that's 1. Yeah, because this one is electrical conductor, electric cables is a good conductor of electricity. Good conductor of electricity and ductile. They can be stretched into wires. Does that make sense? I hope that makes sense, guys. What you're doing is you're picking the property which matches the use of this. Yeah, I like it. Now, can I also now mention there are some metals you've got to know. So let's just quickly go metals to know. Metals to know. Number 1, iron. Iron. Yeah, everybody loves iron. So we know that iron is strong and cheap. There's lots of it. Very strong, very cheap. Yeah, but it has a problem. It rusts. Yeah. And the other metal to know is aluminium. Aluminium is an amazing metal. We love aluminium. Yeah. And we love aluminium. Why? Because it's lightweight. Don't put that it's strong. I don't know about you guys. Have you guys ever dropped your MacBook on the floor and dented it? Not that strong, really, is it? Lightweight, and corrosion resistant. It doesn't rust. By the way, you can't actually say that. Annoyingly, nota bene, you can't say it doesn't rust. You have to say corrosion resistant, just to underline that. We love aluminium, though. Right. Okay. So now that we know the properties of metals and we've reminded ourselves from year 7, what we now need to do is we now need to talk about what their structure is. So first things first, diagrams. So structure of metals. There are 2 diagrams you've got to know. Diagram number 1. Diagram number 1. So now this is commonly referred to as the simple diagram of metals. And in reality, we're going to leave this one behind, but it's still useful in certain questions. So the first thing is, diagram number 1 looks like this. Oh, come on, Mr. Duncan. So metals, pure metals, yeah. So let's put this as aluminium. Why not? This is aluminium. So this diagram shows number 1, it's a solid. Number 2, the atoms all same size. Number 3, they are in layers, form in layers, and those layers, and this is where a question now comes along. Yeah, question. Why are metals malleable? Why can we shape them? Answer. Let's do it in green. Answer. Form in layers, and those layers can slide. Done. So this diagram is used. Today I have mocks, lad. That nice. Yeah, sorry, Jose. I'm not going to post that one, just because your last word. Jose says, I have a mock today. Oh, that's funny. So That there is the explanation for why they are malleable. Learn that, they love that. Right, diagram number 2. Now, this is the real one. This is now GCSE. Diagram number 2. So, metals are kind of cool because they have a really special property. That's that they can conduct electricity. So, look at now how the picture changes. Number 1, a gap appears. There was no gap before. You guys have to learn to draw this. Now, what we're going to do is we're going to focus on sodium metal, make it easy for ourselves. Now, what you'll notice is this. Sodium plus Na plus Na plus Na plus Na plus and Na plus. Now what I'm going to do is show the little electrons buzzing around. Doesn't matter where I put them. So metals are very special. So what's now happening? So it turns out that we understand that the reason why does anything bond together? One of the biggest questions in the whole of chemistry. All of chemistry. Question. Why do things bond together? And there's one answer. Why do things bond together? Answer. To gain a full outer energy level of electrons. That's why they bond together. So the question is, how could a metal gain a full outer energy level of electrons without bonding to somebody? And they do a really clever trick. They throw their electrons into the air. So if we were to draw this picture, here is sodium metal. Here's an atom of sodium. So sodium, go to our periodic table. Sodium is here. So this is for Jose's benefit. So just to tell you, Jose, it's really useful this. The periodic table is an amazing thing. They're going to ask you in your things like in your mock, they're going to ask you things like write down the electronic configuration of sodium. So first shell has 2 elements in it, 1 and 2, hydrogen and helium. So that gives you the number 2. Then the next energy level has 8 elements in it. So that becomes comma 8. And then the third one is sodium, where we stop at number 1. So the electronic configuration of sodium is 2, 8, 1. Let's now turn that into a picture. First shell, 2. Hydrogen, now a helium. Second shell, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And then sodium, 1 electron in the outer shell, and we're done. So there's sodium, 2, 8, I should color code it. 2, 8, 2, 8, 1. There's its electronic configuration. Now we all know that sodium needs to lose 1 electron. Because if it loses 1 electron, what it will have is this. 2, 8, and it's full. It just needs to lose 1 electron. Now it's got a full outer energy level. It's a foe. Right, so it needs to lose its electron. Now, the really, really clever thing about this is when they're in metals, what they do is they have no choice. But if I take 3 atoms of, let's take 6 atoms of sodium. Sodium, 1, 2, 3. Wow, did well there. What I'm now going to do is I'm going to 2, 8, 1. There's sodium. Right, I'm now going to do what you guys can't. I'm now going to clone and copy this. Copy, paste. Copy, paste. Copy, paste. Copy, paste. Copy, paste. Right. Here's what they now do. They do something really clever. Every atom in the metal now throws their electrons into the sea. And that is the correct term. They just throw their electrons off. And what happens is nobody owns the electron. Nobody does. It's just floating around in the sea. So what that now becomes is this. Na plus, a giant lattice of cations. A giant lattice of cations. All of them become +1 because they lose their electron. And now we have a sea of electrons. This gap is filled with electrons that they have all thrown into the sea. And this is, so the description here, and by the way, there would be, just to let you know, this sea will contain 6 electrons. The reason why is because each atom in this particular picture is going to lose 1. So the second learning objective is describe the bonding. So we need to be able to A, draw a picture and then use words to do it. So the description of this is describe question. It's another exam question. Jose could very well be in your exam. Describe the bonding in metals. We can even do one better and say, actually choose a metal if we like. Here's the answer. Bullet point number 1. A giant lattice of cations. Remember, cations are positive ions. They're positive, they're cats. A giant lattice of cations. Giant lattice of cations. Lattice just means it's in a pattern, in layers, if you like. Giant lattice of cations surrounded by a sea of, and this is now a key word, change my color, capitalize, delocalized electrons. So we now have a sea of delocalized electrons holding it together like glue. And those electrons flow through the structure. They can move. So what you realize is, if you were simply to look at it, what you have is a cation and a cation, and in the gap, you have a negative sea of electrons. And therefore, the force of attraction is the electrostatic attraction between the cations and the negative sea. Everything in chemistry comes down to the electrostatic. Everything. And there's your description. You can even draw a picture and you get all the marks as long as you write down delocalized electrons somewhere, because that is a key word. Just to explain the word delocalized, yeah, the word local or localized means in one position. But in metals, they're not localized. They are free to move around. They are delocal. Yeah, basically they're foreigners. Although, can I just point out, that doesn't actually make sense because I'm a foreigner in Malaysia, but I wouldn't say that I was delocalized because I am localized to Malaysia. Yeah, delocalized would mean a traveler. Travelers are delocalized. Yeah, that's better. So there's the description. Now, the cool thing is you can do some really fun stuff with this. So I just want to now show you something. So let's pick two metals from my table. Let's pick sodium versus magnesium. So if I go sodium metal, let's have a look at what's oh, it's just come up saying, do you want to attach your pen to your tablet? That's bad news. Let's have a look at what sodium metal looks like. Sodium metal. I don't actually have this in my collection. Sodium metal. So sodium metal is a group 1 metal, and you can cut it with a knife. It's relatively soft, yeah? But it's a silver shiny metal, definitely malleable. You can definitely turn it into wires if you wanted to, yeah? Great conductor of heat and electricity. Not strong though. So what does sodium look like? Sodium looks like this. Na+, Na+, Na+. Let's do 6. Right. Now I then say that each atom of sodium has lost 1 electron. Let's put 6 in the C. Right. What would magnesium look like? Magnesium metal would look like this. Magnesium, 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 magnesium. Now this time, what would the cation be? And in this case, magnesium is in group 2, which means they're going to lose 2 electrons per atom into the C. They just throw them up into the air. Nobody owns them. And it becomes an Mg2+. How many electrons? Here's a question to the class. How many electrons am I now going to draw in this C, please? So in sodium, we had 6. How many am I now going to have in this C? I wonder if anyone can post that on the chat for me. Well, meter, 2 per atom, but in this diagram, they're absolutely right, well, in total 12. Well done, everybody. Masaru, well done. Lauren, well done. Mita, well done. Zaina, well done. So guys, so in this case, we have a lattice, oh, what a mess that was. A lattice of +1 cations and a C of 6 electrons. Over here, we have a lattice of 2+ cations and a C of 12 electrons. Which metal will have the higher melting point, please? Which one's going to be bigger? Which one's going to have the higher melting point? Let's see how many people can get it. Come on. Come on, Year 10. You can do it. Who's going to have the higher melting point? Come on. I've got faith. Come on. Mita says magnesium. Next. Come on. Who else? Masaru agrees with you. Julius agrees with you. Well done, guys. That is well done, Zaina. It's absolutely correct. Sodium has a melting point of, I believe, about, blimey, I'm going to 98 degrees Celsius. 98 degrees Celsius. And magnesium has a melting point of about, I believe, 600. A big jump. I've got to check that now. Sodium melting point. All sodium melting point 98 degrees. Winner. And magnesium. Okay, this one was a bit more of a stretch. I don't know magnesium's. I think it's about 650. So close. So it's higher. Yeah, nailed it. Thanks, guys. Well done. How cool's that? we can now predict differences in melting point. How cool is that? More charge on the cation, more electrons, stronger metallic bonding, stronger electrostatic attraction, therefore higher melting point. So I'm tempted to do another one. So just out of interest, what about potassium and calcium? Which one would be higher? So out of potassium versus calcium, who's going to have the higher melting point? It's a good question. Who? On the chat, on the chat. On the chat. Oh, nailed it. This is easy. You guys are on this. Of course it is. Potassium +1 +1 +1. You know it because the periodic... Guys, do you... Oh, Julia says potassium. No, not Ian. No. It's not potassium because potassium is in group 1. It's going to form a +1 cation. This is K+, 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 K, and 1 electron per atom in the C. Calcium is going to form a 2+. Calcium 2+. Calcium 2+. Calcium 2+. 1, 2, 3, 4, 5, 6, 7, 8. We're done. Higher melting point. Potassium has a melting point of about, I don't know, 70, 60. Eek. I don't know my numbers. Potassium melting point 63. And calcium. We know it's going to be higher. +2. 842. Boom. Like it. Way higher. Winner, winner, winner. Chicken dinner. Gotta love metals. So we can now describe the bonding. We can draw a diagram. Whoop, whoop. And they ask you to do that lots. Diagram? Yes. And describe? Yes. We just describe the picture. Yeah, describe and diagram. Now we just need to explain these guys. Malleability, we've already done. They're forming layers and the layers can slide. Do we need to learn the melting points? No, Mita, no. But you do need to be able to predict which ones are higher than others based on your understanding of metallic bonding. They will do exactly what I did, Mita. Exactly what I did. They're just going to say, predict which metal has a higher boiling point. Yeah, they're just going to do that. And they're just going to say predict it. And then ask you to draw a diagram of one of them. That's all they're going to do. So, no, you don't need to be able to, you don't have to learn any melting points. Mita, the only reason why I know melting points is because I've been dealing with them so long. And even then, I don't know them very well. Yeah. The last question is conductivity. So why can metals conduct? This is the next exam question. Whoop, need to try and find a spare place. There we go. Last question. Why can metals conduct electricity? And dead easy. I think you all now know the answer. Metals, bullet point number 1. Metals have, change my color, capitalize, delocalize, that is always worth a mark. Delocalized electrons. 1 mark. 2nd mark. The electrons can flow through the structure. We're done. Boom. That's it. And amazingly, guys, that actually brings us to the end of metallic bonding. 1 lesson at GCSE. It's that simple. I don't need to go any further with this. You can go further. And it's nice just to give you that tiny little step into A-level. But just for the time being, what I'm going to quickly do is, so for those, do you know what, Meter, I should, I need to share with you my support sheet. So this is a reminder for my year 10s in the class, and also Meter, I definitely need to share this with you. This is my support sheet. And in reality, what I need to do is I actually need your email, which is a bit frustrating. What I'll actually do is, I don't know if I can do this. If I post that link on the, if I post that link on the YouTube chat, and then if I change my share things, I need to have it set up so it shares with anyone with the link can view. No, I don't want that. What I want is, I don't want, yeah, that's awkward, isn't it? It doesn't viewer, commenter, yeah. I don't really want anyone to be able to, I wanted that to say, to confirm it. That'll be interesting. Is this a good idea? Don't know. I don't know if this is a good idea. Meter, go to that link and see if you can log into the support sheet. Right, guys, metallic bonding, there it is. Line number 10. So what this is, you can ask her for the email. And I know, Zina, but I don't want her to post her email address on the chat. Just add her in, I know. Anyway, let's go to Metallic Book 2, just for fun. So if I go to Metallic Book 2, we can actually have a look at some exam questions as well and see where these appear. So, first thing. So question number 1, the property of substances can be explained in their bonding. What? Is that Meter? Is that Meter? That might be, nope, that's Callista. Meter, sorry, I didn't listen. If I posted a link there to what I created. This is a year 11 support sheet for GCSE. And this support sheet has linked in loads of exam booklets that I've made per topic. And what you can do is you can use this as part of your revision. Now, I do need to tell you how to use this booklet. It's really important that when you realize that this is not a test, these booklets are designed for revision. What you do is you do one question at a time, and then the mark scheme is at the end, and you mark as you're going along. If you did these as tests, it would actually make you a worse chemist. It could break you as a chemist, because if you got answers wrong, then you'll repeatedly get it wrong, and you'll learn the wrong answer. So if we go to the booklet on metallic bonding, I've opened it up twice now. There we go. And it says, explain why aluminium is a good conductor of electricity. 2 marks. Nice and easy. So aluminium has delocalized electrons, and those electrons can flow through the structure, conducting electricity. You're done. Yeah, let's check the mark scheme. So Meter, the mark scheme is at the end. There's the mark scheme, and it says, question number 1, delocalized electrons, delocalized, oh, it's only 1 mark. B, that's weird. Have I gone to the wrong question number 1? Delocalized electrons and can flow. It doesn't actually, that's really stupid. 1 and 2. M2, so, yeah, so first mark is for saying delocalized electrons and they can flow through the structure. Yeah? So I'm marking it as I go, always. Next question. Suggest why aluminium is ductile. As I said in my lesson, ductile and malleable have the same explanation. Why can I shape a metal when it's solid? Because they're in layers and those layers can slide. It's the same reason for ductile. Yeah, if you want to have a look at what that looks like, when you have the atoms like this and you pull it, the layers can slide over each other. Yeah, and you can pull it then into wires. Yeah, you're pulling it into wires. And it's said all to do with the being in layers and those layers can slide. Let's go back to the booklet. There. Next, let's find the next metal. That's not metals. Explain the reference types of particles. I'm looking for the metal. The problem is there's not many metal questions here. It's got electrolysis there. State why metals such as titanium are good conductors of electricity. They have free delocalized electrons that can flow through the structure. Explain why metals such as titanium are malleable. The atoms are in layers, and those layers can slide. Let's have another one. There's ionic, there's covalent. I'm sorry, that booklet really is terrible, by the way. There's far too many non-metal questions in that. Let's go to book 1. Yeah, let's go to book 1. Sorry about that, folks. I'm having to, you realize that these booklets are not perfect. Oh, same one again, titanium appearing. Electrolysis. Oh, metal cans. Aluminium is used to make state. 2 properties of aluminium that make it useful for this. You should not refer to the cost in your answer. Why do we love aluminium in cans? It is malleable, so we can shape it into a can, and it is corrosion resistant. Yeah, because we're going to put food in it. We don't want it to rust. Yeah. Why is iron malleable? It forms in layers, and those layers can slide. Why can iron conduct electricity? It has delocalized electrons, and those electrons can flow through the structure. Suggest, high melting points. Oh, right, I need to run that one. Last question of the day. Last question of the day of our lesson today, folks. Correct. Well done, Meter. Aluminium. Good job. Right, last question of the day, folks. And then my lesson is over. Question. Oh, my pen's dying. It's dying. Oh, no. I need to charge it. Battery's about to die. Question. Explain why magnesium has a high melting point. Guess what we're running, folks? Whenever you see this, explain melting point. What are we running, everybody? Answer. Susan Boyle sings Nelly the Elephant. We know this, guys. Whenever we see explain melting point, we must run Susan Boyle. Yeah, let's run it. Structure. Metals are tough, you see, for this one. Right, I'm going to do it in green, make my pen a bit bigger. Susan Boyle sings Nelly the Elephant. Well done, Julius. Structure. A giant lattice of cations. I know metals are hard. A giant lattice of cations surrounded, you've got to go the whole hog with metals, surrounded by a sea of delocalized electrons. We've got to describe the structure. Delocalized electrons. Next, bonds. I'm going to space this. Bonds. The electrostatic, there is the electrostatic attraction. Electrostatic, you realize that it's always electrostatic. Electrostatic attraction between cations and negative electrons. Electron C. Strength, very strong. This attraction is very strong. How many are there? It's giant. We said giant. Number, there are millions of attractions. If you actually said bonds there, they won't care. Energy, lots of energy needed. Lots of energy needed to break. Done. The giant lattice of cations surrounded by a sea of delocalized electrons. There is the electrostatic attraction between cations and the negative electrons, say. This attraction is very strong. Millions of attractions, loads of energy. We're done. And that brings me to the end of metallic. That's the hardest question in metallic, really, guys. It's the hardest one. So I'm going to leave you there now, everybody. I hope Mita got onto the support sheet. I hope she did. Right, guys, I will see you all next lesson. Metals are done. One lesson on metals, and it's all boxed off. Next one we're moving on to is covalent. We're going to be starting with giants, starting with the giant covalent. Mita says, hey. Yes, Mita, what's up? Me Duncan. Do you mean Mr. Duncan? Does anybody have any questions before I go? Any questions at all? Cool. Right, guys, if you've got any questions, send me a message on Google Hangouts, and I will see you all next lesson. It says required permission. Perfect. I will allow that. I will have had an email meter. I will have had an email asking me for permission, and I will click yes to it. Just wanted to say, no, that's perfect. I'm so glad. Let me just say yes to you. I won't do the email live on thing. I'll click yes because it will have come through to me, and I hope it helps. And I'll see you next lesson anyway. I'll see you soon.